So, my beautiful class, this right here is the definition of a slope. Hear it. Slope is the measurement. Slope is the measurement of the steepness of a line. Steepness of a line. So, any line that we are given, whether it be that one, or whether it be this one, or if it is even this one going down, they all have a steepness to it. No, not the angle, the degrees that it has and whatnot. It is the measurement of its steepness. Think of it as the famous staircase, right? If you have a staircase that goes like this, then like this, then like this, then like this, then like this. If you were to draw a perfect line, well, yeah, somewhat perfect. That is the slope of the line. These unit of measurements. It goes a certain amount of either inches or centimeters or feet or whatever measurement you want. It goes a certain amount this way. I'll just put an X for it. And it rises a certain amount of measurement, right? So we'll just put Y there for, it could be 2 question marks. It doesn't matter. It goes a certain way out. It goes a certain way up. And it does that same measurement which creates our line, a perfect line. We aren't going to be talking about curves. We aren't going to be talking about, the parabolas and all that you go on and learn in upper level college math. We're just dealing with the famous line right now. So, what was this called again? Could somebody tell me? I heard a from somebody. The coordinate plane, which does happen to have 4 quadrants. But this right here that you see is the coordinate plane. So, my friends. So here I have a straight line on the coordinate plane. What we're going to do is find the slope of this line. But first things first, before we learn how to find the slope, before we get into the tips and tricks that you got to watch out for, the stuff that always trips students up all the time, before we go into all that, you guys have to first learn something. That little something is this formula here. Yes. Yeah. This is the famous chalkboard. Watch. This is the famous formula that's going to be your best friend from this point forward. Y equals mx plus b. Has anybody heard of y equals mx plus b? Okay. So y equals mx plus b. Think of this as the formula for every line that we're going to deal with on a coordinate plane. This is the formula. Don't know what that means? Just think of it like this. This is the way that the name of a formula will look like. For instance, a line, let's say we draw a straight line, it can be written out like y equals, 1 over 2x plus 3. Then you don't have to write what I'm doing right now. I prefer following along. Let's say we're given another line that happens to look kind of similar, but is a little bit lower. It might look a little different. Its linear equation which is what y equals mx plus b is called. That's the formula to all linear equations. That line on the right, its linear equation, or its name, might look a little different, like 2x plus 1. Tomorrow we're going to dive deep into this. We're going to be able to match, if we're given a linear equation, if we are given a y equals mx plus b equation, we'll be able to match it to the appropriate line. We will be given lines, and we'd be able to write out its linear equation. All that comes tomorrow, right? But just think of this as the beginnings of what we'll deal with. But all I really want you to first grasp is, when it comes down to the famous linear equation, y equals mx plus b, the m is slope. The m is the slope. So today, all we're going to do is master slopes, all right? Come tomorrow, we will master how to find the b. We'll find out what it means, right? We'll get into all of that. And then you'll be able to put the two together to find the linear equation of lines. All right, get it? But for today, we must master how to find the m, aka slope. So there's two ways to find the slope of a line, either graphically or mathematically. What do you think we're going to be doing first? We will be learning how to find the slope graphically, as in when they give us a line, how do we find the slope of this line? That's graphically / visually. And then in a little bit, we'll learn how to find the slope of a line mathematically, which is useful because sometimes questions won't give us lines on a graph. They'll just give us numbers. So, but first things first, let's find out the tips and tricks to find the slope of a line visually, graphically. First things first, my friends, pretty straightforward. You're given the line. Okay, good. Find me 2 points that lie on the line. So, here's your first tip for the day. Every quarter I do get somebody with a smart comment saying, well, Neil, there is unlimited, so many lines or points on the line. And that's true, right? But when I say find me 2 points, oopsies, I mean 2 points on the line that are actual points. Something that we can actually read. What I mean by that is this. A point that lies right on the grid intersections. So all of the, well, I'll just stop I'll just not waste my time. Oh my God. I'll not waste my time. Just note that all these little intersections of the actual grid itself, this whole coordinate plane, those are points that we are looking for. So, on this line, try to find a couple points that are right in the cross beams of the actual grid. Let me give you one. If we look really closely, we could find one right, right there. You see that? See how it's right in the cross sections, right? The last thing I want you to do is ever pick a point that's like right, oopsies, I don't know, like this one here. Do you see how it's just in the middle of the grid? It ain't there. It ain't there. It ain't there. It ain't there. It's not on the actual cross sections. is just in the middle of some random grid line. When I say look for 2 points, I mean the ones that are actually on it. That's going to be extremely important. So how do you find the slope of a line? Step number 1, find 2 points. Locate 2 points. And it doesn't matter how far apart or how close they are. If I were to go for this one here, okay, you guys might spot another one, but let's say I'm just one of those students that spotted this one here. So I just located 2 points. Again, you probably spotted another one that was closer. It doesn't ever really matter. You just have to locate 2 points. And this is what you're going to do, my friends. You are going to have embedded into your brain this famous name, phrase, I don't know what you want to call it. But it is the famous rise over run. What that means, this rise over run, this little fraction layout, is how your slope is going to look like. It's going to be in fraction form. Sometimes it might come out as a whole number, but I'll show you that in a second too. So what you do is quite simple. You do what it tells us. You start at 1 point. And then what you do is count these steps, rising or falling. It doesn't matter, but the goal is to rise or fall. Count the steps it takes to get parallel to that other point that you've located. So if we count the steps, watch. Starting from here, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. You are now in perfect alignment with the other points, right? But make sure you keep track of those steps. We went up 9 steps. Now tell me, how many steps are you going to take to run to the next, to the other points? From this location right here, let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 steps. Guess what? 9 over 12, I mean, yes, that is your slope. But if we go back to the first couple weeks, we did develop our skills of simplifying fractions, right? And plus, you do have a calculator that has a nice little fancy fraction button that all you got to do is put it there, push enter, and then it simplifies it for you. But tell me, can somebody tell me what 9 over 12 simplifies down to be? Let me move this aside. Oopsies. Just follow the arrow. All right, 9 over 12. What does it simplify down to be? 3 over 4. 3 over 4 is the slope. The simplified, it's the slope. That's what you should always have, the simplified version. And it makes sense. Do you know why? Let me erase all these steps that I did. And how about we switch it up a bit? Let's go back to this point right here. With my newly found slope, which says rise 3, run 4. If my slope is correct, if I rise 3 and then I run 4 steps, I should hit another point. Should. So if we go here, we start there, and then we rise 3, 1, 2, 3, and then I run 4, 1, 2, 3, 4. Did I hit another point? Did I? Dang it. Perfect. We probably have a good 5 minutes before it completely shuts down. So, that's when you know you found the correct slope. And check it again. From this point that you just located, go up an additional 3. Where was it? Right here? Go up an additional 3 steps. 1, 2, 3, and run an additional 4. 1, 2, 3, 4. Perfect. Another point. You know that you've located the correct slope. If you were one of those students that immediately spotted those 2 points, you would have immediately got it. You would have immediately gotten the simplified slope. You would have just bypassed the whole simplifying step. But the reason why I got the 2 points that were farther apart from each other was to show you that it doesn't matter how far apart the points are. As long as you count your steps accordingly, and as long as you simplify correctly, you'll always find the simplified slope. You rise and then run. But it all comes down to first locating 2 points. Does that make sense? All right, let's go over some other trickery stuff. Okay, so now I have this line here. How do you find the slope? I want to find my m. I want my m, aka slope. Okay, my friends, well, you already know the steps. Locate 2 points, rise over, run it, and then, write it down. So locate 2 points. I'm going to get you one. This one right here. Does anybody want to shout out the ordered pair of the next point that you see? Let's practicing our skills from yesterday. Give me the X and Y location that I should put the dot at.
2 and 8. I see 2 and 8, but I also see, yeah.
2 and 7, you mean?
Yeah.
Yeah. Okay, good. We went for the farther ones. Yeah.
Triangle.
So 2 and 7. All right, perfect. That was an actual point, right on the crosshairs. Good. So what do I do? Rise and run it. By the way, we're going to get into the negative slopes in a sec, so maybe I'll do that later. Never mind.
Is it easier if you find closer together ones?
Yes, it is. If you can, always do it. But, I mean, in this specific case, we were a little rushing on the test, and we didn't really analyze well enough, and we happened to get those 2 farther apart points. Still doesn't matter, because we could still find the simplified slope at the end. So here, I'm gonna start from here, and I'm gonna count my steps up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My rise is 10. So, I was over here. Count how many steps you run. 1, 2, 3, 4, 5. Can 10 over 5 be simplified? To what? Two over 1. 2 over 1 is the same as saying 2. All right? This is an example of a slope that's an actual whole number, 2. But the thing is, like we learned in the first couple of weeks, any whole number, we already know it's over 1, right? So if we're going to practice this, right now we are finding the slope of a line. What if we were to work backwards? What if we were given the slope of 2 and you had to go, graph it? That's its own little other technique that we're going to learn. But if you're ever given a slope of 2, keep note, or a slope of 3, or any whole number, keep note that it is over 1, which means you are going to rise that whole number of 2, and then you're going to run 1. So let's test that out. What if we start here? What if we rise 2, 1, 2, and then we run 1? 1. Did I hit another point? Yes. Rise 2, 1, 2, run 1. I hit another point. Rise 2, run 1, I hit another point. Those are whole number slopes. Whole number just means the number over 1, which means you rise 2 and then you run 1. Rise, then run, rise, then run. Very quickly. Very, very quickly. Yeah, I'll introduce this right now. I'll introduce it right now. So you found the slope. The slope is 2, right? 2 over 1 or 2. Whichever way you write it, it's correct. But it must be in simplified form, you guys. So here's the thing that you always got to check for. Check always whether your slope is a positive line or a negative line, or a positive slope or a negative slope, I should say. How to check that? Well, there's many ways. A lot of teachers like to teach the whole, oh, it depends on your directioning, right? In this case, you rose, oopsies. In this case, you rose 10 and then you ran 5. So that's positive. If you had to in any way fall and then run, that's a negative because you fell at one point. Or others teach if you reverse and then rise, like your directioning determines whether it's a positive or negative slope. But I found a really cool technique to really, really, really help you out. Whether you like it, I don't know. But just do this, my friends. Just do this. Draw a car on the line with its hood always facing the right. Just draw a car on the line and then tell me, is the car going uphill, uphill or downhill? So guess what? The M, the slope, is a positive 2. The car is going down uphill. When the car is going downhill, your slope is negative. How about we see an example of this? We're going to use the same techniques that we did. Is at the end, once you've located your 2 points, once you've done your rise and run, once you've simplified your fraction, once you've done all that, at the end decide whether this is positive and negative just by drawing a little car. So let's do this. It's clicking out. Oh man, all right. Kind of off by a little bit, but that's human error on my part. So I see a point there and I see a point all the way over here, and yes, your goal is to always find the 2 closest points, but I'm just making our lives harder and just getting 2 of the farthest ones if possible. So let's say you're a student that started here. It doesn't really matter what point you start at. Your goal is to always rise, which is your vertical, right? So either you rise or you fall, doesn't matter. And then you run. You run whichever direction. So let's say you started on that one. How many steps does it take to get parallel to the next point? Well, let's count it. 1, 2, 3, 4, 5, 6, 7, 8. 8. 8. 8 is my rise. All right, how much do I run by? Well, starting from this location where I left off, 1, 2, 3, 4, 5, 6. Come on, it can do it. Possibly not. Okay, time crunch. Where did I leave off?
5.
Let me just count again. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I ran 11, right? Let's simplify. 8 over 11, can it be simplified? Wait, did I count this correctly? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So let's do this one more time with a brand new clean slate. My M. Let's say you start there. You go 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Always check whether it could be simplified. 9 over 12, what is it simplified? 3/4. Then is when you ask yourself, is this a positive or negative? Don't ever skip that step. It's important. Draw the car on the line with its hood facing the right and tell me what direction is it going to. It's going downhill, right? It's going down. That's all that matters. No, it doesn't matter if the line happens to cross on the negative side where, you know, both x and y are negative. No, it doesn't matter if one of your points are in the negatives. That never matters. It only matters of that car, whether it's going downhill or uphill. Because it's going downhill, guess what you do? You just tack on a negative on your 3/4 and then you're done.
What made you point the car down, not up?
Because I said always draw your car with its hood to the right.
It'd just be like if it was pointing up to the right, it's positive, and it's pointing up to the left,
Yeah.
it's negative.
You'll very quickly be able to spot lines right off the bat, whether it is a positive or negative line. Let's say I make a very rough coordinate plane here, and I drew a line there, a line there, a line there, or even a very skinny, even skinnier than that line. You'd be able to see the pattern that they all have, which is all positive, right? Meanwhile, negative line, like that, like that, like that, like that, those are negative lines. You'd be able to spot it quickly. But for some, it's difficult to see a line and know. So my suggestion is just draw the car at the end and then tack on a negative to your slope or leave it as a positive slope. But yeah, you'll very quickly develop the skill of spotting when a line is flipped to the right or flipped to the left. You'll be able to spot that quick. But it's no matter what, it should be your last little question, whether it's a positive line or a negative line. What really matters is locating those 2 points, rising and running, getting those, making sure it's as simplified as possible, then worrying about positive or negative. Yes?
So we know that M is equal to.
But yeah, that same line, let's say you were one of those students that started at this point. In this specific case, unlike before when we started this one, like Steven said, we had to fall and then run, right? But in this case, you were one of those students that just started on this one. You rise. How much do you rise by? 9. Same amount of steps. In this case, you do reverse. How much do you reverse by?
12.
It's 12. And then you simplified it the same as before. You simplify it down to 3/4. And then you ask yourself, is this line a positive slope or a negative slope? And either you draw the car or you just look at it. Whatever skills you develop. But you say that at the end. You ask yourself that at the end because that's when you decide to either tack on a negative to your slope or you leave it as a positive slope. So let's find the slope mathematically. This is important for the next example I'm going to show you. Using that same line that we just did, the same exact line. What I want you to do is always locate 2 points, right? You just located it. But now give me the ordered pair of both of those points. So there's this one. What is the ordered pair of that line, of that point? I have a, was it 5, negative 5?
Yeah.
Oh, you were talking about this one here?
Yeah.
I was asking for this one.
Then you
Oh, sorry. Yeah, you're right. Boom. There he goes. So this one over here, my friends, is negative 7 and 4. And then, yes, 5 and negative 5. You just wrote the ordered pairs, right? This is what we're going to do. We're going to use this thing called the slope of a line formula. Now, if you don't know what a slope of a, or if you don't know what a formula is in general, it's pretty straightforward, all right? A formula is used to, as a little template, if you will, to fill in with numbers and then outputs whatever it is that you're looking for. Somebody write this down because I'm going to ask for it in less than 30 seconds. So if you wanted to, let's say there's a formula out there to, if you wanted to determine how many bread you sold from your bread business, right? You wanted to find out the total amount of money you make in a day. You create a formula. To find the total amount, what you need to do is multiply the amount of bread that you have, and then you multiply it by the amount of dollars it goes for, and then you divide it over 2 just because, I don't know, that's what the formula tells us, right? And then you happen to add 0.10 because of the taxes, I don't know, and then outputs the total. I just made this up, by the way. But this is what a formula does. It looks like this. And then you punch in the data that's necessary into each variable. You solve it to find the total amount of money you made in the day. Well, there is this beautiful, beautiful formula that math created for us. And this formula looks like this. You can write it down. It's actually on the worksheet today, so good for you. But it's a formula that looks like this. In order to find the slope, aka m, I already told you that, what you must do is y2 minus y1 over x2 minus x1. Does that look like gibberish so far? It won't be in a second. This is the formula, the slope of a line formula. This is the formula to find the slope of any line mathematically. So, what does this mean? Well, did somebody write down those 2 ordered pairs for me? If so, what is it? Negative 7, 4, and then I believe it was 5 and negative 5? All right, good. So those are my ordered pairs. The thing is, how are ordered pairs written like? Well, we already know this from yesterday. Ordered pairs are always written xy, xy, right? But because this one right here happens to be my first one, like physically from left to right, because it's my first one, guess what? That's my x1, that's my y1. Because this is my second set, that's my x2, and that's my y2. Hooray, you just found the your x1, your y1, your x2, your y2. Guess what you do? You just punch in those numbers into your formula, whip out that calculator, punch it all in, push enter, and then out pops out the slope already handed to you. Watch this. By the way, can anybody remember from week 3 or week 4, I forgot what it was. What is the rule for substituting variables with numbers? Parentheses. So all I'm going to do is rewrite this whole thing. M equals, but I'm just going to save my but and put parentheses. And then I'm going to punch in the designated number. What should go in there? My y2. What is my y2?
-5.
Beautiful. What should go in there? Well, it says y1, so tell me, what's y1?
4.
4. What should go in this one there? The formula tells me x2. What's my x2? 5 minus x1. So what's my x1 that should go in there?
7.
You could solve it by hand, or if you have that calculator, you could put this exactly the way it is. Obviously not the m equals, that's what we're trying to find. But all you gotta do is punch in all of this, push enter, and out pops your fraction. But because we're math geniuses at this point, let's solve it by hand. -5 minus 4, what does that equal? -5 minus -7, what does that equal? -12. -9 over -12 is the same, your calculator would dish it out for you, is the same as saying +9 over...
No. 5 minus -7 is giving +12.
Pause. It's a +12, not a -12. My apologies. Sorry. So that actually doesn't become, well, duh, it was a negative slope. So guess what, my friends? There is your slope. -9 over 12 is the same as saying -3 over 4. And yes, the slope, the negative sign will be in the middle because either it's a -9 over 12 or a +9 over -12 still gives you a -3 over 4. My apologies. But is that what we had last time? Isn't that the slope that we had for this line?
Yeah.
3 over 4. That's because we solved it mathematically. So if you're given a graph, either do this method or the other one is fine. But the thing is, what if we were just given this? What if we were literally just given 2 points, 2 ordered pairs, with no lines, with no graphs around us? There's only one way to solve this, and that is by using the slope of a line formula. No, your answer better not be, oh, I'll just, whip out the graph paper, draw out a coordinate plane, locate those 2 points, get a ruler, draw a line, then do my rise over run, because I prefer the graphical way of solving the slope. That should be the last thing you should even think about. Why? Because human error. You might accidentally draw your line, a little squiggly, right? Which, if you're off by just a centimeter, could trip you up. It's already happened to me. And I have a tablet. And that takes way too much time. And for those of you taking your GED, you ain't going to have graph paper, right? You're going to have a little whiteboard, and you're not going to have no straight edge to be drawing no grids, right? You have to just, if you're given 2 points, any 2 points, you could be given this on, no, you will be given this on the test. My quiz, GED, WAMAP, CASAS, well maybe not the CASAS so much, but any test, they could just give you this. And they could ask you, what is the slope of the following line that passes through the following 2 points? You have to do everything that we just did, which is use the slope of a line formula. Let's solve this one very quick. And this time around, take out them calculators, because you're just going to actually punch it in. So if you recall, this is my x1, this is my y1, this is my x2, this is my y2. The formula, if you've forgotten, is y2 minus y1 over x2 minus x1. So tell me, what should go in this first space right there? What did you say?
2.
Oh yeah, 2, and then the y1 is 4, so it's 2 minus 4. And then what about my 2 ones over here? Negative 5 minus positive 1, or yeah, minus positive 1. Practice the skills of just punching that into the calculator exactly the way it is. Use the fraction button. Punch it in. For those of you that still don't have those calculators, obviously we still got these ones. But these calculators have the famous fraction tool. So all you got to do is punch the fraction tool. Punch all of that in and push enter. Why not just solve it by hand, Neil? Well, this one's pretty straightforward, just like the one before, right? But obviously, math is math. They're going to probably throw some bigger numbers our way, and why waste time when you could just punch it into the calculator exactly the way it is and have the calculator throw the answer out. What's the answer for this?
1/3.
Did we get a 1/3?
Yeah.
That's just because it spit it out already in simplified form. So again, here, there is no graph around. And yet they still ask for the slope of a line, of this line. Why? Because those 2 points does represent a line. So this is the mathematical approach. In the worksheet today, you will be given just 3 quick little graphs that you have to practice your little rise over run for. But the majority of the rest is going to be the mathematical approach. Don't think the graphing way is something to be pushed aside, because that comes handy for tomorrow.